actually outsmart a human hacker? We're about to find out. In this explainer, we're putting artificial intelligence to the ultimate test, seeing if it can take on one of the most complex, creative, and, let's be honest, adversarial human tasks out there, breaking into websites. First, we'll quickly set the stage with the web's massive security problem. Then, we'll meet the new AI agents designed to be our digital detectives. And then, we'll throw them into a brutal digital gauntlet called HackWorld. The results? Well, they were not what anyone expected. And finally, we'll dig into what this all means for the future of AI hackers. So let's just start with the big question, the one that hangs over this whole topic. Could an AI really find and exploit a flaw in the websites that you and I use every single day? This isn't some sci-fi fantasy anymore. It's a real and critical area of research with some pretty huge implications. To really get why we even need AI hackers in the first place, you've got to appreciate the sheer scale of the problem. The modern web is, well, it's a massive, complex, and unfortunately a very vulnerable place. I mean, think about it. Web apps are basically the gateways to our entire digital lives, right? Our bank accounts, our private messages, our health records, all of it. The research calls them prime targets for a reason. They are the front door to everything we want to keep private. So let's talk about one of the most common and, frankly, sneaky attacks out there. It's called cross-site scripting, or XSS for short. This is where a hacker manages to inject their own little piece of malicious code into a website that you totally trust. Your web browser then runs that code thinking it's part of the site, and you have absolutely no idea it's even happening. Okay, so here's how it goes down. An attacker posts a comment on a blog, but hidden inside that comment is a nasty script. Now, if the website's developers didn't do their homework and sanitize that input, that script gets saved right into the database. So now, every single time a new, unsuspecting user visits that page, their browser runs the hacker's code, maybe stealing their login info, and just like that, the attacker has access to their account. It's a simple trick, but the consequences can be devastating. So the web is full of these little holes, and finding them with human security experts is expensive and it takes forever. The proposed solution? A brand new breed of AI agents designed to think and act like hackers to find these flaws before the bad guys do. Now, hold on. These are not your average chatbots. We're talking about a whole new class of AI called computer use agents, or CUAs. And here's the game-changing part. They can actually use a computer. They can see the screen, understand what's on it, and decide to click buttons, type text, and navigate around just like you or me. It's a massive leap forward. Okay, this diagram might look a little complicated, but the idea behind it is actually pretty simple. It's basically a feedback loop for the AI's brain. The AI model takes a look at the screen, a snapshot. Then it thinks, okay, what should I do next? Maybe it decides to click a link or type something into a box. A controller then performs that action. That changes the screen, and the AI gets a new snapshot. It sees the result, and the whole process starts all over again. See, look, decide, act. That's how it learns. And that brings us to the million-dollar question, the one at the heart of the HackWorld research. Yeah, these agents are pretty good at general computer tasks, but can they apply those skills to the super specialized, tricky world of cybersecurity? Can they actually think like a hacker? To answer that question, researchers had to build a digital gauntlet, a place to really separate the true AI hackers from the wannabes, and they called it HackWorld. Honestly, the best way to think about HackWorld is like the world's first ever driving test for AI hackers. It's a standardized course, it's got a bunch of different challenges, and it's all designed to see if these AI agents have what it takes to navigate the treacherous roads of the internet without, crashing and burning. And this is what success looks like in HackWorld. The agent sees a little warning message, and that piques its curiosity. It forms a hypothesis, starts poking and prodding at the website's code, and after some trial and error, boom, it finds the vulnerability and pulls out a secret flag. You can see it right there in that little treasure chest. That's the proof. That's how it wins. And listen, this was no walk in the park. The 36 different applications in HackWorld were built using a ton of real-world technologies. Python, JavaScript, PHP, Java, you name it, the whole shebang. This test was designed to be as realistic as possible. All right, so the stage is set. We've got our advanced AI drivers, and we've got a seriously difficult driving course. The only question left is, how did they do? Well, to put it mildly, it was a bit of a car crash. So, this is it, the moment of truth. How did the best and brightest AI models, the state-of-the-art agents from the biggest labs in the world, how did they actually do on this test? They failed. I mean, spectacularly. The absolute best performing agent managed a success rate of just over 11%. Most of the others, including some of the biggest names in AI, scored a perfect 0. Zilch. They couldn't find a single thing. Ouch. But this wasn't just a simple failure. It was a massive reality check for the entire field. And the why, the why, gets right to the heart of what AI can and, more importantly, can't do right now. It's this huge gap between knowing facts and knowing what to do with them. I mean, this table says it all. Just look at Claude Force on it. On general computer tasks, it does pretty well, almost 44% success. But on the hacking tasks in HackWorld, a big, fat 0. This right here is the smoking gun. Being good at using a computer does not make you a good hacker. And when the researchers dug into the data, they saw the same mistakes happening over and over again. The AIs would pick the wrong tool for the job. They'd hit a simple 404 not found error and just give up. Their attempts were really superficial, and they'd often get stuck in these endless loops, like a broken record, just trying the same failed action again and again. And this really gets us to the core of the problem. The bottleneck wasn't perception. The AIs could see the screen just fine. The problem was cognition. It was thinking. They just couldn't chain all the little clues together, adapt to new information, and form a coherent, multi-step plan of attack. They knew all the facts, but they had no idea about the strategy. So where does this leave us? Is the dream of an autonomous AI security analyst dead? Not at all. Not even close. This research just gives us a very clear and very humbling picture of the long road ahead. And this quote from the researchers themselves just nails it. They found that simply building bigger, stronger models isn't the answer. Success didn't come from raw power. It came from, and I quote, planning, discipline, and strategy control. In other words, it's not about having a bigger hammer. It's about knowing how, when, and where to swing it. So, you see, this isn't really a story about failure. It's a story about finding a new frontier. And it leaves us with this one critical, nagging question. If today's AI can't yet think like a hacker, what kind of AI do we need to invent? How do we build an artificial intelligence that can not only understand our digital world, but can actually truly defend it? That's the challenge, and the race is on.